developers, we're going to now discuss object properties. And let's go start with here at the file 21 property. So what I did was I took the variables that we had been working with in one of the string exercises to start us off with, right? Because what we're going to do now is we are going to take this object that we had done before, and we had created an address where this address was a string. But what we're going to do now is actually going to make it an object, because if we were passing around these 5 strings, we would actually be passing around these 5 strings inside of an object. So we're going to start to see what that looks like now. And always coming back to our little graph, because we want to see how this is going to be represented and how this is going to behave here in memory. All right, so there's our object. What we want to start doing, and so look, there's more than one way to do this. I'm going to start off by using, and I'm just going to reorganize this a little bit. I'm going to put my address at the top. And instead of saying var street is equal to this, right, var street is equal to 100 Main Street, that actually creates a separate variable. It creates a separate address in memory where this is going to be stored, and we have a pointer called street that's going to point to it. Instead of doing that, what I want to do is I want to use dot notation. So we've used dot notation already when we worked with like the console log function. So if I say address.street now, I want to say address.street. So this now, and I'm going to delete that part of it. What this is going to do now, in JavaScript not being a strongly typed language, the variables here are dynamic in that they let us, the objects let us add properties and functions to them. And so what I've done right now is that to this object, I have added a property to this object address, a property called street. And that street now is a pointer to this value. And we're going to see how this is going to be associated here and how this is going to be visualized over here on the graph. And you can see here now that this object, within it, there's a property called street. And it points to this particular value, 100 Main Street. So the property, again, very much like the variables when they're declared out here, they're pointing to a value and address in memory. Because it is part of this object, we draw it here around with a little box around it, like a row of cells. So we're going to do the same thing to these other properties, right? Where I'm simply replacing the var space with an address dot. And they're all going to now be part of the object called address. Normally when we deal with an object like any object, there's probably some type of identifier. So I'm just going to make up some number. This is going to be the ID of this object. So I created an object and it has an ID, some random ID. I also purposely just wanted to have a number in here so we can look at it so it's not just all strings. Now, whether this object is an empty object literal or an object full of properties, I can still say var, I'm just going to call it add2 for, no, that's going to be confusing. I'm just going to call it address2. Actually, let me give it a better name. Maybe I'm going to call it shipping address. And I'm going to say shipping address is going to point now to the same location, right? Shipping address is going to point to the same location that address does, right? That is a more technical explanation as to what's going on here. In English, we would simply say that we're assigning address to shipping address. We're assigning address to shipping address. But when we deal with reference types, what we're really doing is saying they're going to share a pointer, right? They're going to have 2 separate pointers, and they point to the same object, right? And in case this helps, let me go ahead and just do this over here. That these 2 variables, variable 1, variable 2, right? Those two variables, they have separate pointers, right? Look, they have two separate lines, but they point to the same object, right? To the same starting address in memory, where here we have now 6 properties. That's what that feels like. That's what that looks like. So what more could we do? Let's go look at the console. Actually, what we're gonna do this in the console. We're gonna put that in the console over there, and I'm gonna console.log. That was strange. We're gonna console log address in a few different spots so that we can see how this is gonna behave. Let me put my semicolon at the end. So when it's empty, after it has a few properties, and then even I'm going to console log both of these shipping address and address. I'm going to hit save, and let me make sure my console is showing and over my head. So again, a little preview into using our developer tools. Our addresses showed up in the graph just like they did before. The first thing that got logged here, oh, look at that. What happened here is really interesting. You see how I first, and this is our developer tools. So see, on line 25, long before, on line 25 there, and on line 25 here, long before I gave it any, let me close this property, long before I gave it any properties, when it logged with nothing. You see no properties. But now, because of just the nature of how the tools work, when I clicked on that, it actually said, go to this address and let's see what's at this address. Let's go to this place where this pointer is pointing at and show us what we got there. And that's how we got this information here, right? Because the pointer didn't change, right? The pointer did not change here. 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 The variable did not change where it was pointing to. Really cool to see, though, that as it logged to the screen, it logged what it had at that point in time. Okay, so let's do this again, and I am going to comment out a ton of stuff so that we can see that. So we can see that working. So here it is. Our address points to this empty object, and if we open this up, there's nothing there, right? Because there was nothing there, nothing got logged in between these little curly braces. But now if I go back and I say, in fact, let me just do this. I'm just going to put these 3 in. I don't mean to have you in here. Let's take you out. So I'm going to log, and because at the time that I log, there's nothing inside of it, it shows empty. But when I encourage the developer tool to say, hey, let me see what's inside this object, it actually shows up, okay? Because what it did was it waited, right? So this is a little, this feature, this is actually not a nice word, but it describes what's going on. It's a lazy. So it performed a lazy operation, meaning it didn't do a job until it really needed to. And that was, hey, let me show you what's inside this object. That operation didn't happen. That interrogation of that object didn't happen until I clicked the little caret to expand the properties. And there, boom, the properties are actually what I found at this particular address location. Super cool. So those 3 properties, right, ID, street, and apartment, are what are going to show up if I put this console log back in. So if I put that console log back in, I see ID, street, and apartment. Because ID, street, and apartment were the 3 properties that I put there. So it had that to render. But again, if I then do the rest of this stuff here, right? So there's still only going to be 2 lines of console log. In fact, I can actually, 2 lines that I console log. If I console log the entire object right now, which is address, let's see what happens. You can see actually even more gets logged because that's what's currently there. Okay. Now, just like this says ... here, I'm not saying that everything always gets logged to the screen because it will summarize it when it gets to be too much. But what we're seeing is just the behavior of the fact that it knows that when I click on here, it knows, and right, this is what's happening. This object that's being logged there, the variable, the pointer, is the object that we're interacting with. And so when we said, hey, open up and show me what you got, it showed us more than what it originally had, which was here, which was the last two properties that we added on there, which was city and state, right? The last set of properties. Actually, it was city, state, and zip code. Meanwhile, if I logged it immediately right now, we can see that there it is, right? And there it is. And then finally, shipping address is the same thing as if I would have console logged. If I click up arrow in there and I want to see the shipping address, there we go. It's pointing to the same object. These two pointers. So if I said shipping, because the two pointers point to the same object, I can say equal address. Right, I can do this using the comparison operator, right? The strict comparison operator. This is essentially saying, are the pointers pointing to the same object? And the answer to that is true. Okay. Now, if I had this, look what I'm going to do over here on the right. What I'm going to do, let me zoom out a little bit. I'm going to take this entire address. And what I'm going to do is I'm going to just copy paste them. And I'm going to make a new address. I'm not going to do this equal assignment thing. I'm going to make a new object called shipping address. I don't need to console log everything. Let me get rid of the console logs. But now I am creating the exact same object with the exact same properties, where the properties are the exact same thing. And we will see that when the graph renders, what we see is that, yes, we have two objects. One is called address, one is called shipping address. They point to two separate objects. Even though the values are the same, when I go to compare them, hit up arrow, the value is going to come back as false. Because the comparison is the comparison of pointers. The pointers point to two different things. Those are two different addresses in memory. So false. These guys are not equal. All right. I could dynamically here say I'm going to declare a variable called shipping address. I'm going to call it mailing address. I'm going to say the mailing address is now I'm going to assign to mailing address the original object that we've called address. All right. So if I do that and I do mailing address, I see I have something there. Now, real interesting, right? So now if I say mailing address, is that equal to what was it? Shipping address? No, it is not equal to the shipping address, because I didn't tell it to point to shipping address. I told it to point to address, and those two objects are equal. All right. We've talked about the objects. We talked about creating properties on these objects. Here is how we assign the values to these properties. Let me get rid of these console logs. Yes, let me get rid of these console logs because I'm console logging the entire object. And I am having these two pointers. Let's leave those two pointers in place. Let's clarify something. What if I only wanted to see, and in fact, I'm just going to do this from the console first, and I'm going to show you in writing the code. What if I only wanted to see the apartment of a given address? I would say I would have to access the property value with address, right, using dot notation, dot apt for apartment. And if I hit enter, I get access to that particular variable, okay, to that particular property value. So similarly over here, I can say address.apt. And if I simply do that, that's not going to do anything because there's no console log here. And there's no variable assignment here. So if I wanted to capture that value and put it into a variable, I assign it to, right, the assignment operator, I assign it to a new variable called my apartment. And because of that now, I have a variable, and it's going to be a separate variable that points to, again, a string that holds the same value as apt, right, apartment B. I could do it that way. Again, if I wanted to assign it. If I simply wanted to console log it, I could console log just that property. And that is going to be different than console logging the entire object. Again, remember the entire object, it gave us a little caret. So similarly, if I wanted to at the very top, before I assigned any value to apartment, it's going to come back, look, it's undefined, right? If I click here, it's going to show me that, yes, I am logging here as console.log. This is coming back on line 25, as undefined because it has yet to have a value associated with it. Later on, I actually console logged that apartment, and it did have a value. So it did have a value at that point in time. My apartment variable has a pointer, and it's pointing to this variable over here. All right, because and I wanted to show you that because sometimes when we say, hey, can we extract a particular value, like street, and again, it doesn't mean to match. I like to call these guys different names and the names of the properties. My street is shipping. Now I'm going to use the shipping address, that street. There's shipping address, that street. And it's going to be under my street, coming up here in a second. There's my street, and we have 100 Main Street, right? Because it points to that same value. This shipping address is here, right? This actually shipping address, I had repointed it. This guy actually doesn't need to be there. Let me clean that up, right? Because that guy, all those values I essentially wiped out by reassigning this value right here. So now this is good. Now we have done string concatenation before, right? So if I wanted to, I could take this apartment address, and I could say that right before I do anything else, the apartment is equal to the apartment plus B. So I'm going to live in an apartment that's called apartment BB. All right, so we see it logged, apartment BB. All right, now I could do this. If I do it out of apartment or if I do it out of shipping apartment, the two variables are pointing to the same location. So because the two variables, address and shipping address, are pointing to the same location, we're going to see that my first line here ends up creating the apartment BB. And then what I do is I take that apartment BB and I concatenate the BC to it, but I'm using the second variable called shipping address. And let me just put dashes in here in case it needs to be separated so you can kind of see the change a little bit better, right? Because both of these objects are pointing to the same object in memory. So super cool, right? Or super dangerous because if you once you start passing objects around, sometimes you forget, hey, the object I'm manipulating right here in front of me is also the object that some other piece of code is expecting, or rather not expecting to be manipulated at a different point in time. And in fact, look, this shipping address, because once I have the address object defined, once I have that pointer defined, as long as I do this at some point after I define address, both address and shipping address point to the same object. We are manipulating the apartment value right here. And so now look, because these two are disconnected, look at this, right? These guys, I grabbed this guy after I had manipulated him completely. So that's my apartment. If I end up moving this line here, right, this is going to illustrate that my apartment, it grabbed this value on line 34, apartment B, and after that, you can freely change this value here, right? The same cannot be said if I did this here, right? It doesn't matter at what point I do this. Address, as long as I do this after below address and shipping address gets assigned to address, my apartment at this point is going to be, it's going to contain the dash B. And then at the end, because the shipping address object points to the same object that the address object points to, this is manipulating, it ends up manipulating the same property. The property that the computer finds located at this particular location in memory. So this is us pulling out properties from this object. If, again, I had a number, this is the same thing for a number. Now, if I take this number and for whatever reason, I wanted to say that I wanted to increment this number. We did this before where the shipping address ID If I wanted to increment a number, the long form of doing this is simply saying, let me take the ID value and add a number to it. I can totally do that. And instead of it ending in 78, it's going to be a 79. Or I can do the shorthand version of this and say shipping ID plus plus, and that's going to increment it by 1. And once I do that, the shipping address, both the shipping address and address.id are going to be back to 79, right? Let me do that twice so that you can see it incrementing and getting and ending in an 80 right now. All right, and there's the 80. So now, next part about properties. We've used the dot notation for us to access, to change, to read. So we're talking about reading and writing. Reading, getting values. Writing, setting values. So when we assign a value, we'll refer to that as setting a value. When we read a value, like we're doing here, we're grabbing a value out of the object using, when we're reading the property out of the object using dot notation, we refer to that as getting. So we're going to be getting here because this is assigning. We're setting a property. We're setting a property here. This is also two sets. Here is gets. Okay. Here is an example of a get. I'm getting the value of a property and then passing that value directly, right? Passing that value directly to the log function, right? So here's that. So you'll see that this is why, because we access this property directly, we're reading this property directly from the object, why this value in the console log is actually in sync with this value inside of the object, because we are literally logging the object that exists inside of that object, inside of that value of the property at that time. And that's different than my apartment. My apartment holds an old value, which was read here. It was read here using a get, right? We're getting the value of a property. We're getting that value here, which happened after I concatenated the plus, but before I did the BC. Okay, so that's getting. That's what we talk about, getting and setting using dot notation. I've illustrated the concatenation, but I want to show you as well that we can do the concatenation, not just with the double quotes, but we can come back and use our friend the tilde and use then the little placeholder syntax for this dude. And here we go. Where are we? Oh, wrong one. There we go. Now, using this particular syntax, again, it's easier because I can start doing things like I did apartment there. I'm just going to put a dash at the beginning because I can't think of anything else to put as a prefix. So I've changed the address to a dash apartment. It's a class apartment. And I did that very conveniently using the backticks, which allow me to implement string interpolation there. And notice that inside of the little brackets, the curly braces, I don't have just a variable. I have a object dot property. So super cool. All right. So this is an example. All these examples here are examples of things that I've done to an object after it was initialized. So we initialized this object here. And we initialized essentially a shell of an object, an empty object with nothing in it. You don't have to do that. You can actually, if you knew ahead of time that, hey, I know that I already want it. When I create this object, I know I want it to have a street property. So we use slightly different syntax in here. Let me remove this from here. So no more dot notation for the street. Let me break that out, separate that by a little space. Let me get rid of this guy. Let me get rid of this extra stuff here that we don't need. We'll leave that there. We'll leave this here. So an object initialized directly and immediately with a street, right? So if I did the console log here now, actually, let me put the console log back here. We're going to see that the address object right away is going to log with the street property. So a little different in the syntax, right? when we use dot notation, we say dot name equals value. So it's dot name equals value, where the dot is coming off of the address object. Inside of the curly brackets, when we initialize the object, it's name colon value. Name colon value. And if I wanted another property in here, you can do that. We just got to follow it with a comma and say apartment. And what was it that I initialized this apartment? Here's the apartment. Here's the value right there. So, by the way, this spacing here, for JavaScript, it doesn't matter. If you wanted to, the JavaScript guides would be totally happy with you, is if you put all of this in one line, this extra white space in here, it doesn't matter. The JavaScript engine is perfectly happy for you to create an object, initialize it on one line, and assign it multiple properties. So this comma here is in between. The comma is in between the properties. So again, the name, a very common pattern that you should get used to, right? Name, value. Sometimes it's name equals value. Sometimes it's name colon value, right? Another example of name value pairs, name equals, where the name is here, right? And there we have the equals, and there's the value, right? Name value pairs all over software development. It's pretty much what we do is to move name value pairs to and fro. So I have an apartment there, an object, an address with two different properties. If I hit save, and let me bring this guy back over to the left, we're going to see that our address object is going to render just like it did before, right? With this modified weird version of this apartment, because we're doing this concatenation. But let me get rid of that because that's starting to look a little weird for my eyes. Again, the naming and the initialization of this on one line is very optional. You're going to find that people are going to prefer to put this on multiple lines. And there are two camps of developers. Developers that love the comma on the first line, and then new line for the new property. And then there's going to be the other camp where new line, and we put the comma on the next line. If I was going to pick a camp, I'm actually in this camp where the comma goes in on the following line. And we can do this as much as we'd like. I did street, apartment. Where's my ID? Hey, let me just bring over my ID as well. Here's the ID. And there's my value. I don't need this here. So, and then naturally, as you can see, let me just get rid of these guys now here. We have examples of initializing the object with properties inside of the curly braces. And we have simultaneously then on the same object assigning new properties to this object after initialization. So it doesn't have to be one or the other. It can be a combination of both. Here I've just made sure that we're only going to render with these three properties. And then even more, if I wanted to, look, I don't know I know I'm supposed to have a street. I know I'm supposed to have a street. I'm not really sure what that street number is going to be, but I want everyone to signal. I want to signal to everyone that an address can have a street property. I don't know what it is right now, or for some reason this street property is not there. What's probably more applicable is if I didn't have an apartment, because not all addresses have an apartment, I could do this, right? And leaving this little stub of a property here with a value of null might be a way that I'm representing what an object address is for me in my application, in my system. And there it is. If I was a developer and I got this object from a third-party API and said, oh, what is this? What is it that makes up an address? Yes, I know that it's null, but now I know that maybe I have to leave room for the apartment somewhere in my interface, or at the very least, I now know that the apartment isn't going to be mixed up on this same line as street, right? Because sometimes that gets mixed up on the first line of an address, right? It gets combined in there. So here we are using the object initialization, initializing with properties, and dynamically adding properties after the fact. Let me also then take this address, and after the fact, I'm going to change the address. I'm going to put them now at apartment C. So I am now APT. I am accessing. I am setting the value of the apartment property after initialization, and even though I've stubbed them out in there, right? So it's totally fine. You can create new properties. Here's us setting properties. We're initializing with some properties. I can set properties after the fact, even though they were initialized as null or empty stubs. That's totally fine. That's totally cool. This is the dynamic nature of the JavaScript objects, the getting and the setting. There's very little rules around that. But this is dot notation. This is object initialization. Oh, and if I wanted to, let's talk about this address. For some reason, if I had inside of my address, in fact, better yet, we have an address object. Let's say I had an object called home, because I have a home. And my home has, I'm just going to call it mailing address. So I could put a string here, right? I could put a string here. Let me put something else here so you can see how this is going to render. And I'm going to put just my name here. Again, the comma between the properties. Oh, that's not the camp I belong to. This is the camp that I belong to. So there's a home object. So now we're going to have two objects, address and home. Let me get rid of this. Notice how, the object graph a little awkward, how it drew this little arrow here. Let me fix that by simply declaring the variable shipping address before home, just so I don't get these cross streams here. All right, so this looks better. But what I wanted to do, instead of simply saying the mailing address is an empty string, what I wanted to say was that the mailing address is actually this little object. Bam. All right. And in doing that, now this got a little weirder. We'll see that the address and the shipping address, their pointers still point to, right? Let's bring out the little drawing for this guy so that I can call this out a little easier for you. The two variables, they both still point to the same object in memory. Here it is, right? The object graph is going through some efforts to draw around this object that is called now home. So my home, who owns the home? It's Gregorio, and this is just a regular string. Okay, no big deal there. But notice now that the mailing address property is pointing to the same object that the other two variables were pointing to. Again, this is where you start getting a little dangerous, because very quickly and without too much trouble, I now have two variables and one property pointing to the same object in memory. There's a lot of good for that. There's also a couple of little side effects that might cause problems for us if you're not careful. If you don't, when you start trying to access this object here called 100 Main Street. The existence of this object, the existence of these three pointers, right? Oh, 3 pointers. 1, 2, and 3. The existence of those 3 pointers to that object are really cool, but also then potentially the source of some headaches for you down the road if you don't know what you're doing. So those are those 3. Now, because I did that, because I introduced that, let's talk about this home object, because this is important. And I'm going to do this interactively out of the console. So let me read the owner of home. So if I just wanted to see home, I would type home, and there it is. There's the entire object called home. Let me expand it, and I see everything that's inside of the home object. But again, what I want to see, and let me go full screen on this so I don't block your line of vision here. I'm going to say home, and I want to see just the owner. I want to see Gregorio. So in here, I want to do, using dot notation, owner. I want to type out owner, and there's the owner. Leveraging home, right? If I told you, hey, listen, I want to see the state property, right? I want to see California on the screen. Just like I see Gregorio here on the screen, I just want to see California. Using your developer tools, until you get comfortable with this, you could simply say, okay, look, here I got home, and I want to drill down into the properties to get down to California. And so what I'm about to do is I want to show you how to use dot notation to drill down into objects. We call this drilling down into an object. And what you're going to learn to do is to access each layer using dot notation, right? Each layer you get to drill down into it using a dot. And so until I write the dots, what I want you to look at and think about is that every time I click one of these little carrots, it's a dot. So here's the home guy, right? So inside of home, starting now, right? So if I want to access the property state, what do I got to do? I got to come in from home and I do dot mailing address. And when I do dot, then it opens up these particular variables to me, right? And from after I've done one dot, what do? If I want to access the property state, I simply type state. So off of home, I click dot, and I want to get to the mailing address. Good. So I type out mailing address here because it's highlighted. I can hit tab. Now, in case, again, you don't have to do this all at once. You can do this baby steps. So boom, if I hit enter there, I have found my way to an object that has these properties. All right. I hit up arrow. And if I want to get down, to drill down into this object some more, I can type dot and I'm going to type state. And that gets me to CA. So this is using our developer tools. It's really important that you get used to using the developer tools. Make sure you try this at home. You play with this, trying to get access to all of these properties and values. So mailing address. Where's my mailing address? Mailing address. Mailing address dot mailing address. So you do type mailing address. See, I did the mistake. I tried to access this property without going through home first. For me to access the property called mailing address, I have to go through home. Here's this little graph. I have to go through home. To get to mailing address, I have to start at home. Now, if I simply wanted to access address, I can do that. Address has direct access to the zip code. Hit up at, here's the address, zip code. But if I want to use the mailing address property, right? Mailing address property, it doesn't work because mailing address is not a variable, right? It's not available. It's not accessible to me. What is accessible to me, as shown here in this graph, is address, shipping address, and home. So if I want to find my way through mailing address, what the graph is telling me, I have to go through home. So here comes home dot. Oh yeah, mailing address. Look, you could use IntelliSense to help you out. So in the IntelliSense here, boom. Autocomplete, IntelliSense for developers, autocomplete for people who use Word. So here's the home dot mailing address dot ID, and I hit enter. And even from here, I can do the plus plus. And instead of now it being 78, it's going to be at 79. And so that's, again, same type of behavior that we were expecting from numbers. So that's how we use the objects. You still use dot notation to drill. And this can go many, many, many layers deep, right? But use your developer tools to help you out understand what it is that you need to type to drill down into these objects, okay? So be sure, before you move on, be sure you play with that and you get a little bit more comfortable with that before we go into the next video.